This is John Black, Super Chemist, here to do a Fischer esterification, make an ester. Now this is my third freaking attempt. Both times I failed in the first two attempts. So I'm pulling out all the stops. I'm doing everything I could possibly do to get a decent freaking yield. I got, now Fischer esterification is a reaction between an acid and a base. I have about 40.3 grams of benzoic acid here, and I got about 175 milliliters of anhydrous isopropyl alcohol. So we're going to mix these together. Cap that up so it doesn't evaporate. And I'm going to start until all that dissolves. Like I said, it's called the Fischer esterification. You can see the word ester right in there. It's an acid alcohol reaction. You can think of, now if you put these two things together, they're not going to react. They're just going to sit there all day. It might take 100 years to make some ester out of it. But if you use a catalyst like sulfuric acid and heat, you can drive the reaction to the right. Now, this is an equilibrium reaction, so you only can make so much ester, and then it will stop, unless you do a couple things. Now, I got the molar masses or molar volumes here, and I multiplied them all by 0.33, and this is what I'm using in my, well, not that. That's what I'm using in my reaction. This too would be, all these are 0.33 times. Okay, now you can speed up the reaction with your catalyst and heat, like I said. And if you use too little catalyst, it'll take just so long. I learned that with the first time I tried this last week or whatever. I only used like a mill or two, and I figured I'd be smart and distill out my water with the azeotrope between the isopropanol and the water, but it didn't work out. And my guess is because it didn't make enough water, because there wasn't enough catalyst to speed up the reaction. So anyways, there are some ways that you can shift the equilibrium so that you can make more product. One is using a large excess in one of the reactants. It can either be the alcohol or the acid. I chose the alcohol, okay? And there's a reason, because I'll tell you that in a minute. But you can use a very large excess of one or the other, the acid or the alcohol. Another way to shift the equilibrium is to remove the products. Either one of them, or both of them, all of them, whatever. But at least one will increase your yield. How do you do that? Well, one is a dehydrating agent, like you can use a stoichiometric amount of sulfuric acid, and that will sequester the water. You can use molecular sieves, some type of anhydrous salt like magnesium sulfate. And another way is azeotropic distillation. You can with or without a Dean Stark. I'm not going to use a Dean Stark apparatus, but I am going to distill out my ethanol so that I can distill out the water. So let's think about how much ethanol I'm going to use. Alright, so if I had 75 milliliters of azeotropic isopropanol, the density is this. So I multiply that to see how much that 75 milliliters of azeotropic isopropanol weighs. It weighs 61.44 grams. Now I want you to think about this, okay? If I had 61.4 grams of azeotropic isopropanol that I distill out of the reaction, right? 9% of it would be water. So I multiply it by 0.09. That comes out to 5.53 grams of water. And as we discussed up here, you would get 5.95 grams of water. Pretty much exact, okay? And when I weigh it up, I'll probably just throw in a little extra. So we go down here. We say we need 25.2 milliliters, or let's just say 25, to make the ester. Remember when we was up here, we took 74.5 milliliters, which was a mole, and we multiplied it by 0.33, and we got this. So we need that. Now we want to put in 4 times that, because that's the lowest amount of excess you should put, is at least 4 times. So to shift the equilibrium. So I multiplied that by 4, I got 100 milliliters. As we just discussed, I want to throw in an extra 75 so I can distill it out, right? I can distill it out and get some of that water out of there. So there's another 75, 100 plus 75. I need 175 milliliters total of isopropanol, and that's how much I used, okay? All right, I chilled this stuff down in the refrigerator. I had a lot of ethanol, isopropanol, so it didn't pre-sip out. I put this in the freezer. It's about 18 mils of sulfuric acid. I'll put it in slowly, just a little bit at a time. And I got 6 grams of anhydrous magnesium sulfate. If you can see that or not, I'm going to put it in. Now, why did I use 6 grams of magnesium sulfate? If you look here, this is the molar mass of anhydrous. I know I put the 7 things there, but for anhydrous, it's 120 grams per mole. So this has 7 moles of, can absorb 7 moles of water for every mole of magnesium sulfate. So I times that, I'd get, if I had a whole mole of this, I could absorb 125 grams or milliliters of water. Basically almost the same exact amount, 120. If I have 120 of this, I can absorb 125 of that. So, to get to our thing, why did I choose what I chose? So, if this can absorb 1 mole, right? 7 moles of water, I divide it by 7, right? Because 1/7 of this can absorb 1 mole of water. So when I divide it, I get 17 grams. That's how much anhydrous magnesium sulfate absorbs 1 mole of water. Now, remember, I'm only going to get 0.33 times 1 mole of water because I times everything times 1.33 at the beginning, remember? So I multiply that by that, and I get 5.674 grams. That's how many grams of anhydrous magnesium sulfate I need to absorb 0.33 moles of water. And this is what we figured out was 0.33 moles of water was 5.95, so they're pretty much almost exact. I'm going to put 6 grams in. And I want you to notice this too, that 5.6 or 5.7 grams of anhydrous magnesium sulfate will absorb 5.95 grams. So you might as well say it's a 1-to-1 ratio. So if you didn't want to do the math, you can always just put in 1 gram of magnesium sulfate for every gram of water that you know you want to get rid of. It's a 1-for-1 ratio. It's nice and easy. So anyways, that's why I put the 6 grams in. So now we got it all mixed together. I'm going to throw it on into the reflux and we'll get that going. And remember, don't just throw it on reflux, like instantaneously. This isn't, I remember I chilled this, so it's still cold. So what we want to do is we want to wait until it gets a little bit warmer, you know what I mean? By the time I set up, so we don't crack it, by the time I set up, it should be up to warm, room temp. Well, we got it set up for reflux. You can see it goes all the way up here. I just put a cotton ball in here. It's not in there tight. It's just sitting. It's just loosely sitting to keep the water from the air out. When you reflux, you should probably, here's the whole entire, whatever, here's halfway point. You should probably reflux in between right here. I usually reflux down here. So that way, once you have stuff come out of the top there a few times, you might do the same thing as me, is just leave it down here, you know what I mean? It's only a degree or two, won't matter that much. Anyway, you can also see I got some precip in there. When I put the sulfuric acid in, and plus I got some of that magnesium sulfate in there. But once it heats up, it'll be good to go. I got it refluxing pretty good. You can see. I don't know how long I'm going to do this. It's got to be boiling pretty good because I had them solids in there. So you can see the magnesium, most of it dissolved, and the magnesium sulfate is dispersed throughout the liquid because it's boiling so much. Oh, believe it or not, I refluxed after 6 hours and 20 minutes. Now I got it set up. And the whole time, you should really have a stir bar for this if you're going to use the magnesium sulfate, because it doesn't dissolve. What happens is it settles at the bottom, then the heat heats up, but it can't get through that layer of magnesium sulfate. So the heat builds up, and then it bumps. Your apparatus, you know how it is when it bumps. And then all the stuff goes flying around, you know what I mean? And then it's good for another minute. And then it all falls back down, and another minute after that, boom, it's bumping again. So for 6.5 hours almost, that's all it was bumping. So I switched over to the Star Bar electric heat, even though it's more expensive. And I got a Vigorex column. I'm just basically, as you can see, I'm just distilling it. And I want to get out, remember, 75 milliliters of isopropanol, and that will, if there's any water in there, you know, it'll remove that 6 grams. Let's hope. So this is probably 75 grams. This is probably going to take me at least an hour and a half, probably an hour and a half, because I don't want to distill out my product or anything. So this would count for refluxing too, because think about it, it's still refluxing while it's distilling. And it's taken me 6 hours and 20 minutes. Let's say it takes me an hour and 40 minutes. So if that is not enough refluxing, I don't know what is. Okay, this is about 70 Celsius. See, I don't know if that's a solid or is that biphasic. I guess we'll find out here. I'll pour it in here. We'll get a little bit of hot water and clean this out and put it in there. Yeah, I'm going to stir that up. Okay, I'm going to filter this out. And I'm going to wash this out with some water. I think that might be the product, those globules, those bubbles. Oh, it's starting to. Okay, I got about 35 mils of DCM. I'll throw it in here first. This was the reaction pot. Swirl it around in there. Then move it into this cup. this.